In this video, I will demonstrate how to use Microsoft Excel to solve a linear programming problem. Linear programming is an optimization technique used to determine the best possible outcome, such as maximizing profit or minimizing cost, while satisfying a set of constraints. Every linear programming problem contains several key components. First, there are the decision variables, which are the unknown values to be determined, such as the number of products to produce. In this example, the decision variables are x1 and x2. Next, we have the objective function, which is the equation we aim to maximize or minimize. In this case, we are dealing with a maximization problem where we want to find the maximum value of the given function. We also have a set of constraints, which are limitations or restrictions such as labor, budget, or material availability. These constraints must be satisfied in order to achieve the optimal solution. In addition, the formulation includes non-negativity constraints, which ensure that the decision variables cannot take negative values, for example x1 greater than or equal to 0 and x2 greater than or equal to 0. To make the formulation easier in Excel, it is recommended to use a table structure where the coefficients of the objective function and constraints can be entered clearly. First, we enter the coefficients of the constraints along with the right-hand side values and inequality signs. We then enter the coefficients of the objective function. At this stage, the cells for the decision variables should remain empty because these are the unknown values that Excel will determine during optimization. To calculate the objective function and constraint values efficiently, we can use the SUMPRODUCT formula in Excel. This formula multiplies corresponding values in two arrays and adds them together. Absolute cell references can also be used for the decision variable cells so that when formulas are copied down, the decision variable references remain fixed while only the constraint coefficients change. In order to solve this linear programming problem in Excel, we are going to use the Solver tool, which is specifically designed for optimization problems involving constraints and decision variables. To begin, go to the Data tab in Excel and click on Solver. Once the Solver window opens, the first step is to define the objective function. In the Set Objective box, select the cell containing your objective function formula. Since this is a maximization problem, select the Max option. Next, in the By Changing Variable Cells section, select the cells representing your decision variables, which in this example are x1 and x2. These are the values Excel will adjust in order to find the optimal solution. We can now enter the constraints of the problem. Click on Add, then select the cell containing the left-hand side of the first constraint. Choose the appropriate inequality sign, such as less than or equal to, and then select the corresponding right-hand side value. Repeat this process for all remaining constraints. You should also include the non-negativity constraints to ensure that the decision variables cannot take negative values. In most cases, Excel can apply this automatically by selecting the option to make unconstrained variables non-negative. Finally, under Select a Solving method, choose Simplex LP, as this method is specifically designed for linear programming problems. Once everything has been entered correctly, click Solve, and Excel will calculate the optimal values for the decision variables while satisfying all constraints. For this problem, the optimal value of the objective function is 10 and the optimal values for x1 and x2 are 2 and 1 respectively.